Okay, today's lesson is 3.1, Unit 3. It's all about systems of equations, okay? Here's what a system of equations is. It's two or more linear equations. Example, y equals x, y equals 3x minus 2. These two make a system. Now our job is to find the one solution for this system. The system only has one solution. The solution is any ordered pair that makes both or all the equations in the system true. So the solution to this system is 2, 4. Okay? Now I'm going to show you why it's the solution. Some of you probably already know why it is, but I'll show you. Okay? And the coordinate is 2, 4. On the original document it says 4, 2. I messed that up. Okay, so I put 4 for y and I put 2 in for x. Well, 2 plus 2 is 4, so that equation, that ordered pair is a solution to this equation. Now, it's a solution to this one as well, because when I put 4 in for y and 2 in for x, 3 times 2 is 6, 6 minus 2 is 4, 4 again equals 4. So that's the one solution that is for both of them. It has to be for both. Now, how do you find the solutions, like when you're not given to them? Well, the first way we're going to learn is by graphing. There's 3 ways. We're going to learn the first way in this video here today. It's by graphing. Okay, so I'm going to put the same 2 equations I just had, and we're going to derive that solution from these 2 equations. What we're going to do is graph both the equations on the same plane. Okay, so I like to make a table, and on one side I put y equals x plus 2. The other side I put y equals 3x minus 2. So the y is isolated in both equations, so I know my m here is 1, my b is 2. My m is 3, the b is minus 2. So slope y int, that'd be 1, and that'd be plus 2. Slope y int, that'd be 3, and that'd be minus 2. Okay, so plus 2 is my y-intercept, so I go up 2. Then from there I go forward 1, remember we put a 1 underneath, up 1. Okay, and then once I get 3 down, it's kind of easy to see what's happening. Okay, and then I'm going to set the camera there for a second. So my ruler I take, and now I can see more of the solutions for that first equation with the line extended. Okay, now here we have minus 2. That means every time I go forward 1, I go up 3. So I go up 3, forward 1, up 3, forward. Okay, I already have a point. So I can clearly see they're going to cross at that point. So I take my ruler and put a line through those 3 points. Now, this is the one point that's on both lines, the point where they cross. So that's your solution. Make an xy coordinate, and you're at 2, forward 2, and up 4. So that's why that's how we figure out it was 2, 4. Okay, next problem. Y equals negative 3x minus 3. And we have y equals 2x plus 2. Okay, y equals negative 3x minus 3, y equals 2x plus 2. So the y is by itself, so m and b. The y is by itself, m and b. So slope y int. So the slope, you'd have negative 3, and then minus 3 is your y-intercept. So I plot my y-intercept first. So down 1, 2, 3. And then negative 3 over 1. So every time I go forward 1, I have to go down 3. It's a ratio. So down 3, forward 1. Really, I can only get 2 points. Okay, so I will take my ruler and extend the line through the 2 points. Okay, make sure your line's pretty long here. If it's too short, you won't see where they cross. Okay, next one, slope, y-intercept. Slope is 2, y-intercept's plus 2. So plus 2 is our y-intercept. And then 2 over 1 is going to be my slope. So every time I go forward 2, I go up. Every time I go forward 1, I go up 2. Okay, and they're going to cross, definitely. And this point right here is on both of the lines, so that's the solution. So the solution, we're backwards 1, so -1, and then we're on the line, so 0. -1, 0. Okay, next one, we have y equals x minus 4, y equals -x. So y equals x minus 4, y equals -x. Y is by itself, so m is 1, b is minus 4. Y is by itself, so m is -1, and then b is 0. Okay? So slope y int, slope y int. So the slope of the first line is 1 and then minus 4. So on the y-axis, 1, 2, 3, 4. 1 over 1, so forward 1, up 1. Okay, and the points all kind of run in a pattern together. That's why it's called a linear equation. Now my second one, the slope is -1, the y-intercept 0, so 0 on the y-intercept is the origin. Okay, 0, 0. So I go forward 1, down 1 now. And I run into a point that's already there. So basically that is, I know that's going to be my solution. And that's the solution to the system. It's got to work for both of them. So I'm forward 2, so x is 2, and then y is -2. If you want to check your answers, you can plug the 2 in for the x and then see if you end up with -2. Okay, now the next one. X equals -2, y equals 5. These are both constant equations because this equation has x, but it has no y, there's only x. This equation has only x, but only y, but no x. So that's also a constant. So remember how you graph constants. You make 3 coordinates. That's how I do it anyway. So in the first equation, there's no y, so y can be 1, 2, 3, and then x is constantly at -2. In the second equation, there's no x, so x can be 1, 2, 3, and then y can be will be constantly at 5. Okay, so -2, 1, -2, 2, -2, 3. Okay, it's going to be a straight vertical line because every point on this line has an x coordinate of -2. Now the xy, so 1, 5, 1, 1, 2, 3, 4, 5, 2, 5, and 3, 5. Okay, the points meet here, and it's no coincidence that they meet at -2 for x, 5 for y. Look at that, -2, 5. I'll let you kind of be the judge of maybe how I could have known that that's the solution right away. Okay, next problem. Now it starts to get pain in the butt, okay? X minus 4 equals -4. 4x minus y equals -1. Now you're going to make your table, but you're going to notice you have a problem. That's the fact that the y is not by itself, so I don't know my m and b. Okay? So first I apply a 1 in front of the y and circle it. Now remember, we don't want that y coefficient 1 to be negative, so I'm going to go negative, put a 1 there. Now I can make my y positive and make your 4 positive. Okay, you need to do that. Now you're going to get rid of the -1x, so plus 1x. Again, the first thing is circle your y along with its multiplier, make sure it's positive. If it's not, you just switch the signs. And then I create a 0x and add 1x to 0x. Okay, You can't really see it very good. So line up the equals, you have 1y. Then 0 plus 1 is 1x plus 4. Now I divide everything by 1, okay? That's a 1 right there, okay? So I have y, 1 divided by 1 is 1, so 1x plus 4. Now I know my m and b, okay? Meanwhile over here, the y has a multiplier again of negative 1, because I'll put a 1 there. Well, we don't want that y to be negative, so negative, positive, positive. So I plus 4x, make a 0x over there and add 4x to that. So line up your equals, you have 1y. 0x plus 4x is 4x plus 1. Now we can divide everything by 1. So y equals 4x plus 1. And now I have my m and my b. Okay, so now I'm good to go. Slope is 1, y-intercept is plus 4. Slope is 4, y-intercept is plus 1. So plus 4, 1, 2, 3, 4. And then forward 1, up 1. Okay, meanwhile the second one we got plus 1, forward 1, up 4. Okay, I run into one that's already there and there. Okay. So I make the line that goes through the points. And there's where they meet. So forward 1, 1, 2, 3, 4, 5. So 1, 5 is a solution. Okay, next up we got x plus 3y equals 12. X minus y equals negative 8. Okay, obviously going to be kind of a pain in the butt problem, but we can handle it. As long as you make the wall, circle the y, you already have positive 3, okay, so you don't change the signs. So that's a 1. Again, the whole point of the changing the signs is to make the y multiplier positive. It already is, okay? But I do have to get rid of this 1x by subtracting. Then I put a plus 0x next to the 12 and subtract 1x from there. So I line up my equals, we have 3y. 0 minus 1 is negative 1x, and then plus the constant of 12. Then I divide each by 3. So y equals, don't put negative 3. Negative 3, 1 divided by 3 is a decimal, so you leave it negative 1/3. 12 divided by 3 is 4. Now I got my m and b, okay? Over here, y's multiplier is negative 1. That's not cool, okay? So I need to make everything opposite. So negative 1x, positive 1y, which is the point, positive 8. Okay, so I drop my 1y, and I got to add 1x to both sides, but I got to make it my own 0x term over there so I can add 1x. So 0 plus 1 is 1, 1x plus 8. Then I divide everything by 1. So it's going to be 1x plus 8, mb. Okay, so now I'm good. Slope, y-int, slope, y-int. So negative 1 over 3 is my slope plus 4, and then 1 is my slope plus 8. So positive 4. Then I will be going forward 3, down 1. Or down 1, forward 3. Doesn't matter which one you do first. Okay. Okay, here you got positive 8, 1, 2, 3, 4, 5, 6, 7, 8, and then up 1, or forward 1, up 1. Okay, and they are going to cross at a point. Okay, right there's a point where they cross. Just label it. -1, -2, -3 is my x, and then 1, 2, 3, 4, 5 is my y. So -3, +5. Okay, now we're back to the easy ones. Y equals x plus 3, y equals x minus 1. Don't have to do a lot of work here. Y is by itself, so I have my m is 1, my b is 3. Y is by itself, so the m is 1, the b is minus 1. So slope is 1, y-intercept's plus 3, slope is 1, y-intercept's minus 1. So plus 3 is your y-intercept, slope 1 over 1, so forward 1, up 1. Okay, minus 1 is the y-intercept, so forward 1, up 1. Little interesting thing happens here. The fact that they're parallel, okay? Parallel lines have no solution. Now the reason they're parallel is because the slopes are the same. They start with different y-intercepts, but the slopes are the same. So it's no solution, and that's always going to be no solution if you wind up with the same slope. Okay, next one, y equals -x minus 4, and then 4x minus y equals -1. Okay, so on one side y equals -x minus 4, the other side we have 4x minus y equals -1. So y is by itself here, so m and b can be applied. But here y is not by itself, so I put that 1 there, but it's a -1, so negative, positive, positive. Then I circle my y, I got to add 4x to get it off this side, then create a 0x and add 4x there, okay? So line up my equals, you got 1y. 0 plus 4 is 4x plus 1, okay? Then I divide everything by 1, and y is equal to 4x plus 1. Now you can apply your m and b. Okay, so slope y-int. So the slope here is -1 over 1. The y-intercept's minus 4. So I go 1, 2, 3, 4. And then every time I go forward 1, I have to go down 1. Okay, and then in my next problem, slope is 4, y-intercept is plus 1. So I graph the plus 1 first, then I go, every time I go 1 forward, I go up 4. Okay, and then those are definitely going to cross, we can see that. Okay, they cross, looks to me about right here. So the coordinate about is going to be -1, -3. Okay, last problem. We have 6x minus 2y equals 6, and then we have 3y equals 9x minus 9. Okay, over here, my y term is negative, so negative, positive, negative, then add the 6x. Then make a 0x and add 6x there. So line up your equals, so you have 2y. 0 plus 6 is 6x. Remember, we made our 6 constant negative, so minus 6. Now I divide everything by 2. It's going to be y equals 3x minus 3. Now I have my m and my b. Now here the y is positive. You don't need to move the x. It's already where it's supposed to be. You just go right ahead and divide them all by 3. So y is going to equal 3x minus 3. Funny thing happens here. M is 3, b is minus 3. And the same thing happens over here. M is 3, b is minus 3. So minus 3, 1, 2, 3. And I go up 3, forward 1, up 3, forward 1. Now I'm not even going to worry about the second line, because the second line is just the same one as the first line. So these were actually the same equation, just written differently. Now here's how I write the answer here. Remember, when they were parallel, it was no solution. Okay? When the lines end up exactly the same, it's something known as infinitely many solutions, otherwise known as IMS. Okay?